I wanted to have a friendly chat with all of you. I was told that the viewers are mainly students who are interested in KAUST at the internship level. We have a great internship program at KAUST for undergraduate students and possibly students who are doing postgraduate studies. And also, this talk is for students who are interested in KAUST graduate studies for master's and for PhD. So a little bit about me. As I was introduced, I did my PhD. After my PhD, I went to actually the industry, and I found it to be very fruitful experience. So in the future, if anybody is interested to know about how it is to be in the industry, feel free to email me. We can talk about it. So I worked in a company called Synopsys in the Bay Area in California, and basically worked on computer engineering designs and designing software tools for hardware design. So basically, after that, after 4 years, I became very interested in joining academia. I wanted to do more things that was not readily available in the industry at that point. New cutting edge things, like things outside of the research area of that company. So I decided to go to academia. And it was really great. I'm still in academia. So, and then I became a professor, and then I started actually working a lot with graduate students. I became a chair of the graduate program in the electrical engineering department. And after that, I continued doing my research, and in parallel, I became a department chair of Worcester Polytechnic Institute. And then after that, recently, I was the dean of the School of Systems at Stevens Institute of Technology. And it's in New York City. So actually, the view you see, that was the view from my office, the Manhattan skyline. So anyway, after that, what are we talking about today? What is the big issue that we have? The big issue is actually IoT, for IoT, Internet of Things, which is basically all the devices that you have in your life. As you see on the right side, you see all these components you have at home, in the car, in the street, when you fly, when you travel, when you go, when you come. It's always all these devices. And now all these devices are actually collecting data and processing that. And the key is, all this data, what are we going to do with it, right? We have to take advantage of all this data so we can have a better life. So that is basically what we call the IoT data deluge. And it's basically all this flood of data that we have to work with. And the key here is, as you can see, this is basically, in terms of the impact of IoT on all of our lives, it's in the trillions of dollars, right? In terms of the vehicles, about $700 billion. Cities, in terms of homes, in terms of all the things that we do have. So it's really an amazing investment the world is making in IoT, and we have to be able to leverage all this data that we have to be able to have a better life. So what, in terms of grand challenges of the world, so I picked a couple of things. So there is a grand challenge by the National Science Foundation in the United States. And they're really talking about what I was just mentioning now, which is how to harness these huge amounts of data that are coming to us to really improve science and technology and make our life so much better. And we realizing that this is going to transform research in all fields of science and engineering. Everything we talk about here at KAUST and in other places, it's mainly, we have all this data. How can we have a better design? How can we understand the human? How can we have a better plant? You know, how we can have just a better life in general using all this data that we have? We should be able to design things better and live better. Now, the other thing other than data, which is human and technology. What about all this interaction, right, between people and technology? It used to be that they're really separate, that you have machines and the machines are doing things for us like factories, cars, and so on. And there is not much interaction really between the machine and us like today, right? So now things are becoming very interesting with the interaction of the machine and the human, and how we can really, again, have better designs and better utilization of technology. And if we see, and these are the two themes I'm going to focus on today, is really data and then human, how we can leverage the power of the crowd, the power of the people who are giving us all this data. Also, if we look here in Saudi Arabia, we have Vision 2030 for the Kingdom of Saudi Arabia. And it's really focused on developing Saudi cities, digital infrastructure, how to engage the society, caring for health, developing all these economic cities and smart cities, such as NEOM and futuristic cities. And this is actually the theme of my talk today. It's about smart cities. What does it mean to be in a smart city? Why is it so important? So smart city is basically you have all these connections between all these buildings, devices, people. Everything is connected to each other. So as you can see here in the figure, you know, you have all these wearable technologies that you're wearing, right? I mean, smart mobility. You have you want to know where to park the car if you're going to a heavily congested mall or whatever, right? So you have to be able to guide instead of running around and just wasting time. Now, these wearable technologies for health, they're connected, right? They're connected with they should be connected with your doctors, with your hospital. They should be able to work together, right? So we can, you know, the doctor will know before you know, or the hospital will know before you know that you're possibly going to have something bad, let's say a heart attack coming or something like that. So if we're able to take advantage of all these devices, we should be able to to have a much better life, longer life, and be able to take advantage of all these technologies. So what is it composed of? It's composed of a smart city of all this Internet of Things devices, right? All these devices that we talked about, the devices that you see. And you have, of course, the social media. The social media now is a very integral part of what we do, we like it or not. And all this information on the social media, right? I don't have to just get an information from a device that I own, right? I also have the social media that can give me some valuable information to add to the knowledge I have in terms of all this data I'm collecting. Now I have all this data. What am I going to do with it, right? So we have to be able to use AI and machine learning and data analytics to handle this flood of data that we do have. So that is basically the story, right? And the applications are healthcare, energy, planning of a city, smart homes, that your home is going to be very smart. You don't need to interact too much with it. Everything is connected together, and telling you what to do, and doing things for you, right? You can think of Alexa, for example, and that you basically speak to it like a human being, like, I want this to be done, and it gets done. It's very interesting, and that is just the beginning of where we're going to be heading in the future. A lot of people, I mean, all the governments are investing tons and tons of money in smart cities. This is going to happen for sure. This is happening, and it's going to happen in the future. And we're very proud to have NEOM right here, a very futuristic smart city that's being built in the Kingdom of Saudi Arabia. and it's going to be probably the smartest city out there. And we're very excited to have it here and to hopefully play a part in these technologies that we will be in NEOM and see what kind of things that can be done. So, for example, as I'm mentioning here, there is basically advanced 5G network is being launched in NEOM and other Saudi cities. China is investing $26 billion. I mean, US, 66% of their cities are going to be smart, and they're investing in smart technologies. So this is going to happen, and we would like to be a part of it. Billions and trillions of dollars are being spent on it. So now, in terms of smart city, what constitutes smart city? There is different things that we thought we should attack and we should really look into. One of them is mobility, right? This is an autonomous vehicle, as you can see here. And that's basically going to be, that's happening now. It's not really the future anymore. I mean, it is happening and it's continuing to happen. So I really predict that in the next 5 years, the highways are going to be very different. They're going to be very different from what you see today. There's going to be a lot of autonomy in these cars. They will be able to do a lot of things that you don't have to do. And we expect it to be much safer, right? So there is no more cutting around people and all that. So life will be a little bit easier and less stressful, hopefully, when you drive. So what in terms of smart mobility, what are we, and we call it smart mobility or intelligent transportation. We're gonna, basically there is a vehicular social network. So it's not more we have regular social network. Now the cars are actually communicating with each other. So here in this figure below, you have the Internet of Vehicles. You have all these cars communicating with each other, but you also have the people in the cars, right? Communicating. And you have the pedestrians, people walking around these cars, walking in the streets, right? So they're also providing data, all right? And then you have the traffic lights providing data. So you have all this now, it's no longer just cars, right? I mean, you have all these people now interacting with these cars. So we're calling that, or it's being called, the vehicular social network. And it's composed of the social network. That doesn't mean Twitter and Facebook or whatever. That could be a part, that's actually a part of it. But the interactions of people also is and some devices that also in the network, like a smart traffic light, right? That's producing data, telling you, telling the car you should stop soon, right? And so on. So you're not going to be in full control all the time. So these cars actually have to communicate with each other, have to communicate with the infrastructure, and make decisions based on that. Also, we will be helping these cars, right? I mean, a pedestrian will be helping these cars in a way, or you will be helping, saying I just saw an accident here, right? So you report it. And that's going to be very valuable for us because it's going to improve how things are going to be conducted in terms of the path the car will follow. So these are things that you can see will improve the connectivity between cars, because even if you're in a tunnel, the signal can move from one car to another until it reaches a place that supposedly there is no network. It's deep into the tunnel, but it's using these other cars as just a vehicle for the network to pass through. That's an easy application. Also, smart navigation. I just mentioned you could give an alert that there is an accident right here, right? So a smart car will not probably come, right? It will go find a different route. This will be easier. Also, social driving. That doesn't mean the cars are texting each other. That means basically the cars are interested in a common goal. Let's say they go from point A to point B every day, together, a fleet of cars, right? Like a fleet of trucks going together from one place to another. So now these cars probably can trust each other. They know If they get information from this car, that's serious information, right? So now this is what we just mentioned, which is basically the value of these information coming from these people and the social network, right? So we have to be able to leverage the power of the crowd, right? The power of the crowd. This extra information that I never had before that are coming to us. This information complements the sensors that I have, what I see in front of me, what the car sees. Now somebody tells me there's an accident or something. That's something I didn't know before, right? So it improved the interactivity between the different drivers, between the different cars. It definitely improved the efficiency of the navigation, right? And so on. So these reports that we're gonna get, we are focused on two. We're focused on reports from the crowds, for crowdsourcing from the crowd, and also trying to automatically extract the information from the social network. So the two applications, basically, one is we have to be able to handle textual inputs. So we used an NLP, natural language processor, to handle these texts that are coming. And we'll be able to automatically utilize these data. And depending on whichever request that's coming, we develop that system that basically that utilizes information. Let's say I want a location, or I want to know if it is how heavy is the congestion in some place. Would you be able to measure that? Here is a general example about the weather. I want to know how the weather is like. Okay, so there is all these different things that you may be interested in, and you're able to send it to the crowd and basically get that information, right? We have a nice example we'll show in the next slide that basically we wanted information about a fire, right? So we wanted to be able to use the crowd to provide us this data for free, right? We know that people sometimes are a little curious. They're very interested in fires and accidents and whatever, so they'll take pictures anyway. And then, but we actually developed an app that can that can basically, the human worker can input this data, and the requester will say, I want pictures of that fire on that street, right? So people who are around can, take these pictures, upload it in the app, and then our algorithm will be able to actually filter this data based on, sorry, it's automatically the light went off. So filter this data based on basically the quality of that person, and how much the quality of the picture, and basically if it's redundant, you get rid of it, and so on. So we have few excellent pictures that basically will be able to allow us to get this right information. And this information will be very valuable because the fire station will know how many fire engines they can send, right? What are the capabilities of these fire engines that we need to send, and how many people? Maybe sometimes some big fires, actually all the fire engines in one city is not enough. They're not enough. You need to call fire engines from other places. So that will definitely be of great help, right? Such an application could be similar in terms of navigation, right? If there is an accident, you enter it, just like you have, for example, in Waze or something like that. So now this is so also we utilize this to be able to get data from Twitter. This data here is from the social media. So people can enter data, as I showed before. The crowd can enter data, and we automatically can filter out the good data and take it and use it. And here we can get this data. Here, this is actual real data that we have here on the right side. And this data from the city of Manhattan, in New York City. And you can see on the left side, this is the traffic alerts from Department of Transportation, right? So all this black circles. And then on the right side, the other alerts that are coming from the social networks that were not reported by the Department of Transportation, because people will be faster. They'll say, by the way, there is a problem here, right? The Department of Transportation will take time to have this data. So the social network can add to that data we have. So we can have the power of the crowd, people providing data, and we can have data from the social media. And we utilize all this data. So now this is what I was just talking about in this vehicular social network that basically we utilize all this data to make better decisions. What does it mean? What it means is that, for example, here, this is real-time navigation. So in real-time navigation, we have basically data coming to you here. You have all this data coming from the infrastructure sensors, traffic lights, vehicular social networks, pumping all this data to you. Maybe some official agents, the police is reporting something that in a way that you can actually read it in the car. Also, there is some input by people, right? And then you get all this data, and now you were able to adjust your navigation to have a better route based on all this data that you have. An example is this. So here you want to go from point. You want to go from point A here. This car wants to go from here to the red dot over, right? So the thing is, this is the shortest path. We're gonna follow it, correct? However, as you can see, oops, there is an accident. a road user reported an accident. So we do a time. We check the time. We re-optimize the path every time window. And the window size we control, right? So every time window, we check what's going on. Is that still the shortest path? Should we still go there, right? So in this case, we have an accident. So standard navigation actually would not know that because nobody is reporting, right? So these things are improving, navigation techniques are improving, but this is the whole idea of it. So now your navigation equation, the objective function, actually is composed of two parts. One part is using the data on historical statistics, right? So I have historical statistics. I know that this path is the shortest path, correct? From 30 days ago or whatever. Now, based on the real data, I can have real data, right? And that weight here, you see W and 1 minus W. W is the weight of that real data. How much weight would you put into that, right? That depends also on the user, because somebody will say, maybe this data is erroneous that I'm getting. Maybe there is no accident. So there is a way to handle that. We will talk also about it. So now in our navigation technique, you can see we actually find a path, another path that's actually that's the shortest path. Given the accident, this is the shortest path, not the original path. So that is really the whole idea. So now this is the power of the crowd, as we were talking. Now the question is going to come: how do you know that this data is good data? Is this person is not just playing, and these are not really good data? How would you know? So here, this is a way of handling this uncertainty, right? So there is a level of certainty or uncertainty you can decide based on the quality of this information you're getting, right? So if this is, for example, a trustworthy person or item or a thing, right? That a device that you trust that device based on historical data. You say, that person or that device from that car always gives good data. 95% was correct, right? So you can actually have higher certainty. So you can adjust to that in the way you design the path. So here, this is an example. You start here at this point, and you want to go here. This is your destination, right? So the shortest path is actually here. You come from the starting point, you go to this way, and then you go this way. So if you don't have data about what's going on, you will actually come here and you realize it's a blocked road, right? So it actually just happened to me 3 days ago. I drove somewhere, followed Google Maps, and then boom, it's closed. The road is closed, and the road is closed for a long time actually, but it has never been reported. It has never been reported to the system or to a navigation system. Here I'm talking about a blocked road, even just from a traffic jam, right? Or an accident or something just happened right here. So it gets blocked. So this is this is basically live data, right? Real-time navigation. So after each window, I check what's going on. Is this still the shortest path? And then here, of course, if you don't follow that, you will go here, find it's an accident, and then go back again, go back this way. So you wasted a bunch of time. However, if you use real-time navigation, you already know there is an accident here. Somebody has been reported already to the system through the social media, as we said, or through people, right? So you get this data, and then you basically decide. And now it's up to you based on the certainty. So here you will find that maybe the shortest path could be that line that is in blue, right? So it is really short. However, maybe there is some uncertainty in some part, and I would like not to take a risk there. So I will go with more certainty, more certain people or whatever, people that I trust more. So it will be a little longer. So this is just an example from Manhattan again, that basically we're under simulation that you could save significant time, and then you could take into consideration the certainty level based on the quality of the data you're getting. So this is a summary of what we were just talking about. Now, other area that of great interest to the whole world is drones and UAV, unmanned aerial vehicle. And actually, we're very lucky that at KAUST, we have a lot of experts in that field, including Professor Eric Ferrand, who's a world leader in drones and UAVs. And he works in this area. Here, we're very interested in UAV as a big part of smart cities and intelligent transportation. So we're very interested in that. The whole world is interested. You can see the kind of investment that has been done, in UAV market. So UAVs, they're used for basically monitoring traffic. They're used for as a roadside unit. You can actually take pictures of accidents and send it back to the the headquarters to know what's going on. So you can change route, send a police car there. There's a big accident. Let's go and tell me, Mr. Drone or UAV, what's going on there, and come back and tell me, report that information, monitoring people and guiding people in big events like stadiums or for example, like Hajj and events like that. So it's very, very important. Here we focused on one interesting problem, which is basically optimizing the placement of, we're showing the placements of these UAV charging stations, because it's very important, right? I mean, these UAVs, they run on electricity, they have to be charged. So it's actually take it for granted, but this is one of the key elements, is where do you charge them? Where do you place these stations? So of course, you can look at all these constraints. You want to minimize the times that UAV takes, wasted time going somewhere that it doesn't need to or whatever. You want to make sure the battery has enough to go to these areas. You want to maximize the coverage. You want to be able to have a UAV to go to any place in that square, right? So you optimize the locations based on that. And then that's a very nice problem that we were very interested in, and we came up with a nice solution Here also some new scheme that combines actually UEV as a part of the transportation system. So you could have a bus, and that's a very interesting scheme. The bus actually carries a charging pod on top of it. So now it's a part of your optimization that I know these buses are moving here and going there. So now this could be a movable or a moving charging station for you. Of course, the bus will not go along the same line you're going, so it's gonna go for a short path, short distance. You use that part. So it's a very complex problem, as you can see, and it's really very intriguing. So there's so many aspects that people are looking at into UEV, but so I'm giving one example. So now we talked about smart transportation. We talked about UEV. We talked about, how about infrastructure? Now you have a smart city. How can you call it a smart city if you're not thinking about the infrastructure of that city, right? I mean, it's very key to be able to design the city from the beginning to be very smart, right? To be able to do things in an intelligent way. So one of the items that's very interesting is LiDAR, right? So everybody knows LiDAR, light detecting and ranging, basically laser that gets installed on so many devices that we use. Most famously is the autonomous car, right? So the car I showed you earlier has LiDARs on it, right? So, and these LiDARs actually tend to be expensive. So now, if I want to make all these cars, smart and hopefully autonomous and so on, we need to be able to know what's the surroundings of these cars, right? So a LiDAR allows you to know what's going on around you. So how can we do that in a more efficient way than actually putting it on every car, right? So one way could be that we have these LiDARs, call them here elevated light, the one you see over here, in the streets, right? So you have these LiDARs as a part of your city design. Interesting. So you basically now, right, the car will be able to get these maps and understand the surroundings using all the LiDARs that are in the road network. So, and that's basically a big part of smart infrastructure. It is actually much cheaper than having every car. You may still have LiDARs on the cars, but not as many as you will have if you don't have elevated LiDARs. So you will actually reduce the cost, and the cost will be just an infrastructure cost that you do one time. And then now all the cars that you have from now till whatever are going to be able to utilize this technology. So think of it as basically the light that you have today, right? To light up the street for these cars to see. Now you need to light it up with LiDARs, right? So the LiDARs will be able to tell these cars about the surroundings and so on. So they'll be able to make better and more intelligent decisions in terms of where to go, what is the shortest path, is there a problem here or there, what the car should do. So that's basically a very interesting infrastructure situation here that people need to think of to basically design the city from the beginning to be able to handle autonomous vehicles, and you just design it this way. This could probably be as integrated with the lights that you install in the streets, right? So applications of this, of course, is that you can monitor the crowds if there is congestion, if there is problems in terms of big events, something that's happening. So that allows you to do that. Also here in the traffic, it allows us amazingly to tell us what's going on in the traffic. So because this is not just used by the cars, right, that want to navigate their way, this is used by the basically the traffic organization, whatever it's called, right? So they see that there is congestion here. Maybe we should open more lanes of that highway right? Or more, maybe we should close that area because there is an accident there. Let's just close it to avoid people going there and stagnating the whole road and allow them to go somewhere else. So this allows us to actually the whole system to be a lot smarter. So also one thing here is that one of the challenges is going to be the planning. We have to be able to plan this in a very effective way, and so that we have a better a better design of where to place the sliders. We're going to have limited number of sliders. We want to save the money, just like the UAV charging stations, right? Where if we have 5, where would we place them the best possible way? So the placement is an interesting problem. And also in addition to that, you have basically now these lidars, hopefully you have all this data coming, right? So we need to be able to process all this data. So one of the challenges actually is going to create for the cars and all the units along the roads that analyzing things is that we need to improve what's called edge computing for the undergraduate student. That is something that's becoming very important for us today, is that in general, we cannot just say we're going to keep sending things to the cloud, right? We just send it to the cloud, and then the cloud, there's a big machine lives in the cloud, big computer that's going to analyze everything and give us decisions. Actually, that's not going to be the right way, because a lot of the times you will not have maybe network, right? Your device should be able to make a decision by itself. So it should be smart enough and strong enough and fast enough to handle this data. So a lot of the work that's actually happening these days, it's on what's called edge computing. And that's basically in the area of computer engineering and how to design the device itself to be as fast as possible, in as small as possible, and as effective as possible. So now this is an application here we have on smart health, that we used our smart navigation for a smart health application. This was motivated by COVID, right? So you are here, you're a pedestrian here, and you want to go from this point to this point, okay? So the shortest path is the red path, okay? However, this path has supposedly a bunch of people, okay, and you want to stay away from people because it's COVID times. Okay, hopefully it's going away now. But it could be, let's say, fires. It could be big problems happening in that area. So it's not just based on COVID. It could be dangerous areas, like here it's by congestion, but it could be something else. And you want to avoid that. So actually, that could be a part of the navigation, is based on, we have the data coming from all these IoT devices, and that's how we know it's congested, based on these signals coming out and so on. And we have all this social network going on between all these devices communicating with each other. So we can actually bypass that whole route that has a bunch of people and go to another path that doesn't have many people or doesn't have problems, right? However, you could end up walking a very long way. So one key would be is that where is the optimum point, correct? So the optimum point, you could either, here is the Pareto optimization. You have to optimize between how much you want to walk and versus how much risk you want to have, right? So the same can be applied, as I said, for other issues that it doesn't have to be a pedestrian. This could be a car trying to avoid a place where it has fire, let's say. And here, that's data we've been collecting from a CCT. So this data in the earlier slide, it was from basically, this data is from devices, from IoTs, coming generating signals and talking to each other. Here, this data is from a CCT. So we can actually use machine vision to figure out how much distance between these people and figure out that, okay, this place is probably too congested, so stay away. So that could be another parameter right, in the navigation system. Now, one other interesting topic away now from what we talked about in terms of smart transportation and also UAVs and so on. Now, as a part of smart cities, we should be able to have very smart and intelligent health monitoring, right? So we are doing now, so we need to be able to monitor the population of the population health in a more accurate way, in an efficient way, okay? So here, and this work is a little bit more computer engineering kind of work that we have done and we're very interested in. It's basically you have a signal that you want to be able to acquire from a person. And that signal could be anything, could be blood pressure, could be temperature, could be heart rate, could be actually more complicated, could be a brain signal even here. As you can see, you can actually collect the brain signals and pick them up. You know, there are some devices that can do that. So here, that's a specific technology called deep brain stimulation. But actually, also you can have signals from these from the electrodes embedded in the brain to actually get these signals. Of course, they use that for strong diseases, neurological diseases, like Parkinson's disease and so on. And this technology has been very effective, by the way. So anyways, so you have these signals and you won't be able to understand these signals and maybe do something about it. Maybe synthesize another signal and send it back to that body part, whatever it is. Like what they're trying to do here with this brain signal, basically. Is there a way that we can send, and they actually do send a signal back to the brain, that I can actually rectify the negative impact of Parkinson's disease? So the cool thing is here we worked on designing a chip or a design that basically allows you to take these signals at much lower energy using technology called compressive sensing, right? And that's basically utilizing this sensing signals at below what's called Nyquist rate. Sorry for the undergrads, but hopefully you heard about it. Nyquist rate is supposedly the rate that you should be sampling to get a good signal. So it turned out you can actually will be able to sample the signals at a lower rate than that and be able to retrieve the signal accurately. And so the advantage is, instead of checking, let's say I'm checking a signal, I want to know how the heart rate is changing and so on. And I want to draw the heart rate, right? So that is the rate you should be sampling at, right? Every certain period. Turns out you could actually reduce that and still recover the actual signal. What is the advantage? Is lower power. Lower power. So the device that does not have to check all the time, right? Check at a less frequency, less frequently, you will check that signal. So basically, you're consuming less power and less energy. So that allows you to have better battery life and so on. Just one example, that device actually here is embedded in a person inside the chest. So you definitely don't want to change the battery. So because, yeah, it's a surgery. Here, on the theme of computer engineering and edge computing, we're also lucky. We have several faculty here at KAUST that work in computer engineering and designing efficient systems. Here, some of the work we have done in this area. And the advantage, as I said, we want faster device. We want that final edge device that I'm using, right, to be able to do some computation, some decision making for me, some machine learning, but not that complicated that you have to run it on a cloud. No, like machine learning enough to be run on a device I have, right? So we still want that device to be as fast as possible, as efficient as possible, consumes as less power as possible, and so on. So this is what happens in the design of these devices. So basically, you can, for people who like modeling different effects and so on. So it's actually very intriguing how all these different components on each device interact with each other. How do you model? How do you model these interactions? So, and also once you understand that interaction, how do you actually model each of these components also? And then how, now you understood how things perform or how to model them, how to actually combine all that together and design something that does what you want. So it's actually very intriguing, and it utilizes optimization and synthesis. So, and it depends on the exact area of edge computing or the whatever device, which exact device you're designing. It may require some information in digital design or analog design or even electromagnetics, as you can see here. This is all electromagnetics that is being modeled, but a student does not have to know all that. Probably will know one of them to be able, if they're interested, to design something like that. There are some students interested in accelerators for machine learning that also fall under this category. So what is the philosophy? So basically, we're interested in interdisciplinary research. I love interdisciplinary research. That's why we're in academia. So we can work on different things and learn new things. And we don't have to stop at one thing that we're comfortable with, right? So we go with something interesting, we go and learn it. Why not? You know, and learn something new. That's what actually keeps things and keeps it more exciting and interesting for us, and at least for me. That's something I do like. So we encourage that definitely in our group. And this is something that actually distinguishes KAUST as a university from other places, because there is interdisciplinary research across the whole university, right? We have faculty working in biology, faculty working on design, on robots, interactions of robots, working on signal processing, communication systems, how to design next generation communication systems, chemistry, designing next technologies. So in all these different fields, and actually because KAUST is kind of, it's a big university in its impact, but people are so close to each other. Actually, it's designed in a way that all the labs are close to each other. So it's probably like 10 minutes walk between any lab and the other lab, within 10 minutes, right? But the campus is big, but it's designed in a very intelligent way. So to allow people to collaborate together and work. Personally, we're very interested in our research group in having people who really care about translational research, meaning we want to be able to make an impact on the society. We want to be able to design things that actually people will use, right? So it makes it a little difficult, I have to say, because sometimes we're in a race with a major company, right? That's fine. But at least one interesting thing, we have developed that technology in-house. So we have it. You know, so if we want to use that technology to do something else, we can, because we have that technology. So one thing I believe in is we have to take risk. You have to take risk. You can't just take the easy way and stay in the comfort zone. So that's something I do believe in. Yeah. So, and you can see the future of research is all about really converging between different areas and so on. So these are the different areas I did mention. I'm not gonna go over it, but I will leave this as the last slide. And basically, in smart cities, there is the infrastructure. We need to have the smart infrastructure. We need to be able to utilize the power of the crowd, the ability that people give us all this amazing data that we be able to leverage. And we need to design amazing technology, right? As you mentioned, you know, LiDAR, new generation LiDAR systems, new communication systems, or new generation of communication systems, 5G, 6G, and so on. We need to be able to have all this to play together to basically allow us to have, a very smart way of living and a healthy way and efficient way. So I will leave you here and I'll open the floor for questions.
Thank you, Professor, for these insightful talks with so many applications with respect to smart cities, city of the future. We clearly see there are many elements, there are many application areas with the smart cities. So with
this question, sorry, a student can put it in the QA, I was told, right?
Yes. So please put your questions in the Q&A.
Also, I am available at any time. We can have a meeting, or if anybody is interested. So my email is yehia.massoud, my first name dot last name @kaust.edu.sa. So that's my email, and we can definitely have a nice conversation about any topic you're interested in. So that's something that we like. I like to have. I like to talk to students, and other than students, of course, anybody who's interested to have a conversation on any of these topics. This meant to be a little bit higher level, to just open your eyes on these different areas of research that is going on. And I'm very excited and thankful and grateful to be a part of the robotics class. And you guys have 3 other excellent speakers coming, and I'm very excited to be a part of that.
Thank you, Professor. So we have 4 more minutes, I think. We can get a few of questions.
So I'm seeing the students in the chat that interested in a scholarship and so on. They can happily email me, and then I will forward it to the right person if they are interested. So that's fine. We also have Mashail online, who is handling the student internship program. So we do have, until we get a question. Oh, we got a question? Okay, good. Yes. So there is a question about the collected data from passengers. So is it really trustworthy or not, right? Is it dependable? So actually, we have a way that we can, it's variable. So the system will work on the standard way. There is no problem, right? But if there is a data coming, additional data, real time data coming from people, we will be able to add that to the system and take advantage of it and improve the system. In terms of, is it the trustworthiness of this data? So we talked about that basically this trustworthiness, we actually have a way to evaluate, right? Because this will be a person that we get this data from, will have like a score, a trustworthy score or whatever, and I mean, in terms of the ability to give correct data and whatnot. So you can put that into the algorithm and give it high level of high weight level to take advantage of this data. If that person, you see that not a good history or whatever, you can possibly ignore it. So it is definitely, that's a part of the whole system. So also another part is in the question was the privacy. So privacy is a very intriguing part of this, and I really care about privacy. However, we like it or not, there's a lot of this data out there. So a lot of this data we were bringing in New York and Manhattan, it's available, and we're able to utilize it to basically historical data to know like which path you go, not just the shortest path based on today. No. We know that from 3 to 6 p.m. is going to be bad on Wednesdays, right? Or something like that. So you can actually have very good data already without real data, based on real-time data, based on what you have from the historical perspective. So I think it's very important. The issue of privacy, there's a lot of people working on it. And usually the way it works in technology, in my opinion, is that people do the technology and then they say, okay, now we need to control it. Now we need to do the privacy issue and we need to take care of it and so on. So if you think too much about it in the beginning, you actually do nothing. But there is actually, will be amazed how much data is available. And so on. And that data could also be utilized, let's say, sometimes by the traffic agency or whatnot, to be able to basically save people from wasting so much time in going through places that has accidents, or and so on. Some of the things we actually were working on is that for the ambulance, right? The ambulance will be able to utilize some of this data about accidents and so on, that basically not waste time. You definitely, this is a situation you don't want to waste any time to take a passenger, to take a sick person to a hospital. Also the fire engines. So, as I said, I'll be interested to get anybody who's interested to ask about anything. We can talk later on. The email, I mentioned it, and I'm very happy to be a part of it. And but thank you very much. Thank you very much for giving me the opportunity to be a part of this.